Hello students, this is Ved and today I'm having guys the problem 1.3 from the SS Krotov. Okay, so it is a very interesting problem guys. Okay, I would advise you that if you want you can pause the video right now and you can try this question for 5 to 10 minutes from your side. Okay, and after that if you got the answer uh, something, let's say whatever the answer you are having, you can come back and you can see the solution that I'm going to discuss now. Okay, and then you can cross check also that what you are getting as an answer. It's a very good problem guys. Different or you can say kind of a unique problem that has been like shared by the author here. Okay, so without any further ado guys, let me just formally read once this question, and in parallel I will just make the figure also guys. Okay, so if you see guys what it is saying that a helicopter takes off along the vertical with an acceleration of how much, 3 meter per second square, and the zero initial velocity. So guys, if I just write here solution, so if you see guys here, there is a, let's say this is your helipad. Okay, where the landing of the helicopter generally happens guys. So here at this place your helicopter is there, and now it is going to what, it is going to take off. Its initial velocity is given what guys, 0, and it is going to go up with a acceleration of how much guys, 3 meter per second square. Okay, it is going to go up guys with the acceleration of what, 3 meter per second square. This is the first thing that has been given. Further guys, it has been said that at the point of takeoff, sorry, the pilot switches off the engine, sorry guys, in a certain time t1. Okay, yes, so in a certain time t1 the pilot switches off the engine guys. Okay, so of course it is going up, it is going up guys, and at some moment, let's say your helicopter reaches, okay, and then what, it turned off the engine guys. So what is going to happen guys, let's say at this moment, at this moment guys, your helicopter suppose is going to reach. Okay, and when it will reach here, how much time it is taking guys, let's say it has been given actually t1, and guys here turned off the engine. Okay, turned off the engine. So that is the guys what, second part of the statement. Now it is saying that at the point of takeoff the sound dies away in the time 30 seconds guys. Okay, so what does it mean? It means that guys, that if let's say there is an observer, or you can say a receiver, okay, who is standing near to what, you can say near to the helicopter position. So guys, he or she, whoever is this person, will not be able to hear guys any sound after 30 seconds from the point of takeoff. Means the sound of engine, the sound of engine was available, was available for 30 seconds guys. Okay, for 30 seconds. So this has been given guys. Now what they are saying further, determine the velocity of the helicopter at the moment when the its engine is has been switched off guys. Okay, so determine the velocity of the helicopter, determine the velocity of the helicopter at the moment when the engine is switched off. Okay, assuming that the velocity of sound is 320 meter per second. So guys, sound velocity is given to you what, 320 meter per second. So guys, first let's try to understand the whole picture, like what is the main crux of this problem. Okay, how the person who had designed this problem has been thought about this question. So guys, if you see, the thing is, I'll show you something very important guys. See, let's say when this what you can say, when your helicopter is going up guys, it will be creating this kind of, you can say, the wave pulse. Okay, it will be creating this wave pulse, and it will be coming continuously guys to what, to the receiver. Is this or not guys? Okay, it will be coming continuously to the receiver, and of course guys, from beginning to this very end up to t1 guys, it was coming to what, coming continuously to the person, he was hearing that thing. because there is a continuous wave was coming from the engine, okay guys. But just think about it guys, the last time when the engine has been turned off, after that there would be a last pulse that would have been generated, and that will come guys, and that will reach to you. So basically if you see, there is lot of already coming, but guys there would be this last one, okay, this will come at the end, okay, this will come at the end, and after that we will not be able to hear any other pulses, okay. So it means guys what, for the time t1 we are getting the continuous pulses guys, okay, continuous pulses, and then there is a last pulse that will be guys coming, because they are received by the person continuously guys, they are coming, and then at the last guys this will come and it will be received, and after that there is no further pulse is going to come and reach to your ear, and you are not going to hear. So it means guys, the last pulse which has been generated, it will take how much time to reach here? Of course it will take this distance whatever is given guys, and the velocity of sound. So what we can say, we can say that how much time it will take. So guys if you see, the time that it is going to take, t by last pulse, t taken by last pulse to reach at the receiver end, at the receiver end, is nothing but what guys, it is nothing but what, it is the distance. Let's say guys, this height is how much, h, so h divided by c guys, that is the time that it is going to take. And guys if you see very finally, you will see guys that this time is nothing but what, 30 minus t1, because guys see, up to t1, guys, we were getting the sound continuously, okay, this sound was coming, okay. But at the last guys, there is a one last pulse is going to come, okay, and they were getting received, and this last pulse will come guys. So this last pulse has taken how much time to come here guys? That is what, of course 30 minus t1, because up to t1 we were getting the sound continuously, okay, and the last sound pulse has taken, of course guys, what, because the sound is available for total time of what, the 30 seconds. So of course after t1 the engine has been turned off guys, so the last pulse have generated, and this will reach to the receiver guys in how much time, 30 minus t1. I hope this idea has been settled for you. If this idea is settled for you, then I think this question is finished here only, okay guys. So if you see here now, what we can do, we can just see guys this, that this h by c is nothing but what, it is going to be 30 minus t1, okay. And guys if you see, what I can write now, that the if this helicopter is going up to the top guys, it will reach some height, and it will be having some velocity, let's say v, and that we have to calculate. So this v will be what guys, initial velocity is what, 0, initial acceleration is what guys, sorry, acceleration is how much, 3, constant acceleration only, into what guys, t1. So your velocity will be what guys, it will be 3t1. So if I can guys eliminate the t1 in anyhow by forming an equation, I can get the velocity. So how do we get guys? So if you see, we also know, guys what, that this h, okay, this h is equal to what, 30 minus t1 into what, into c, that is what guys, 320. And h also can be written as guys what, because the particle has gone, this helicopter has gone guys up to the height h with the acceleration of what, 3, and initial velocity is what guys, 0. I can write this equation that v square is equal to what, initial velocity is what guys, 0, plus 2 into 3 into what guys, h. So v square is equal to what guys, 6h. So h can also be written as guys what, v square by 6. So I'll put this h guys here in this equation. So if I put this thing guys, what I'll get, v square by 6 is equal to 30 minus t1 into what guys, 320. So it is a quadratic guys that is getting formed. So if we see t1 guys, we have to replace, of course t1 we have to replace. How do we replace guys t1? T1 is equal to v by 3. So let's put v by 3 also guys. So v square by 6 is equal to what, 30 minus v by 3 into what, 320 guys. So now we have equation in the v only, guys. We have to solve this quadratic and we can get the answer. So guys, if you see, it will become what? It will become v square by 6 is equal to 90 minus v divided by 3 into what? 320. So guys, this will become what? 2. So it will lead us what? V square is equal to 90 minus v into what? Into 640. Okay. So guys, this will become what? It will become v square plus 640v minus, guys, what? It will become 4 and then, sorry guys, this will become 6 and this will become 57 and this is what? Double 0 is equal to what, guys? 0. So guys, if we solve this quadratic, we will get the answer. And for you guys, if you solve this, the answer would be what, guys? It will come 80 meter per second. Okay, so this would be the answer for us. Okay, so if you see, guys, it's a simple problem only. Just we should know that which equation of motions we have to use, and of course understanding of this wave propagation thing, guys, that if the sounds are getting generated, which pulse is going to come and when it is going to reach, all those ideas, if you are able to figure it out, it's not a difficult problem, it is an easy problem. Just the visualization part of this whole question is, guys, is very important. So if you get that idea, I think you can get up to the answer, guys. Okay, so that's it, guys. Okay, that's it. If you have tried this question and you had came to some answer, then you can cross check your answer right now, guys. Okay, so I'll see you in the next video, guys. Thank you so much.